you're looking at the little simulation with charges moving. Okay, perfect. Okay, so Emily Larson, I got a question for you. As you look at this simulation, all right, and I'm not really telling you anything about it yet, just by looking at it, anything strike you about it?
It's pretty. Well, one of the light bulbs is less bright than the other.
Okay, so up until now, and if you've been keeping up with the labs, we've usually done things where the bulb brightnesses were usually the same. Am I right, Emily? Does that sound right? Like they were usually the
Yeah.
same brightness? Yeah, so something's going on here, okay? And that's what we want to get at today. Why on earth would I have different brightnesses here? So here's what I'd like for you guys to do, okay? You don't have to write anything down yet because I'm going to get you to build a quick circuit and we're going to investigate. So what you might want to do is kind of make me small, and you want to go back to Canvas, right? And if you go to your Canvas page for physics, right, you're going to click on the class time sim that I'm hovering over right here. And once you click on that class time sim, you're going to go ahead and hit the button there. And what I'd like for you to do is I'd actually like for you to make this circuit. And the reason that they are different brightnesses is because the bulbs actually have different resistances. So this is the circuit that I want you to set up, all right? And you just, I'll give you a couple of moments there to do some clicking and playing. But in essence, you've got a 10 ohm light bulb, a 20 ohm light bulb, and a 10 volt battery. And I will leave this here and I'll look at you guys in the camera. And if someone has a question, concern, or issue, just pipe up and just let me know if I can help with anything. And I think, is that Annie Brickley? Annie, are you joining us there? Welcome, Annie. I think you'll hear me in just a second. Hi, Annie. Can you hear me there?
Yeah, sorry I'm late.
Yeah, it's terrible. Gosh, there's really consequences for any of this stuff. Annie, if you can hear me, if you go back to Canvas and click on the class time sim, we're building the circuit that I have displayed on the screen here. So if you can kind of manage two screens at once. And once you've got this built, what I want you to do is I want you to take your current meter and I want you to just basically investigate current in a couple of different points. Write down whatever you see. And then remembering how to use this voltage probe. If you have not done the voltage lab yet, you might not know, but the voltage probe, the red side is what we put on like the positive end of the battery, right? The black side is what we put on like the negative side of the battery. So it's verifying it, lo and behold, that is 10 volts, okay? And so the way that this works, the electrons are coming in to the back of the battery and they're going out through the top, the positive end. I want you to play around with voltage in a couple of different spots. If you've done the lab, you should actually know what the voltage is between these 2 points. I don't want to do it because I want you guys to do it, all right? But it's always going into the black and coming out of the red. So the black should always be the first probe that's touching. So if I wanted to investigate what's going on in this light bulb up here at the top, I'd put the red on the going outside and I'd put the black on the going inside. And so I would just touch it and you'd see a number. So I'm going to give you a couple.
How did you get the bulbs to have different values?
So are you talking about the voltage for the battery?
No, I mean the light bulbs. Like one says 20 and one says 10, but both of mine say 10.
Okay, so all you do to change it is you click on the bulb itself there, Anna, and then you see a slider at the bottom where you can change the resistance. So make one of them 10 and one of them 20. Sorry, I didn't make that more clear. Yeah, is that better?
Yes.
Okay. And so I want to give you a couple minutes to just play and explore. And remember the questions that we're trying to get at here, and Annie, you missed this because we'd already written this down, we're just making some observations about what we see about current and what we see about voltage in different parts of the circuit. So if you got a piece of paper and something to write with, just jot down what you observe. I'll go silent for a couple minutes, ask questions if you have it. When you're done and you've got some observations, give me a thumbs up so I can just kind of keep track. Nathan, I saw you with a thumbs up. So observations about current, observations about voltage. Anna, I got you a thumbs up there. Adam, you can give me the verbal thumbs up there because I know we're still camera averse. I'm thinking about letting the beard come in for full, like full on. Yeah. Why not?
Right.
All right. Addie, I got you. Adam, did I hear you?
Yep.
Okay, cool. It'll be a race, Adam, between your hair growing out and my facial hair growing out. Oh, look at that.
Not that short anymore. It used to be way shorter. It was like down to like it was pretty bad a couple of weeks ago.
He's like it's like the unveil. What's that TV show, The Masked Singer? You've been unmasked, man. That's amazing.
Unmasked.
He comes out of the darkness. That's great. All right, Carter, you doing okay there? It's nice to see you. All right, cool. Let's see what we can wrap up here in about 60 seconds more, okay? All right, Ethan, thank you, bud. So Adam, should I ask, was that mom's doing that haircut?
Long story. My mom messed up the first time, so then my stepdad just buzzed it all off.
Okay.
I was going for an actual haircut, and then
Yeah.
it didn't turn out so well, so I just decided to get rid of it.
Former neighbors of ours, mom was giving a haircut to the son who's like 14, and literally just, it looked like it almost would have cut the skin. It was this bare patch right over here. And the other side was fine, but he had this landing strip on this side. So yeah, no, there's some grim stuff going on. All right, let's do this. Let's bring it all back together here. Does anybody want to be so bold as to tell me the easy one? What did you see about current? Addie, do you feel comfortable talking about current?
Yes.
Yeah, go ahead.
It's always the same everywhere in the circuit, and if you increase the voltage, the current will increase as well.
Okay. And that one we pretty much already knew. Like, we haven't seen any circuits, have we, Addie, where the current was different in different places, have we?
No.
No. So this one was not surprising. I'm going to write this down. I'll switch screens in a minute. But the current is the same everywhere. And that's a really big idea. So it didn't matter that I had different resistances here, right? The amount of charge flowing per second is the exact same anywhere. Now I could play around with these numbers just a little bit. All right, let's take this 20 ohm resistor, and you can play along or you can just kind of watch my screen. Let me ask you this, using your thumb, all right, if I were to increase the resistance of the 20 ohm, maybe make it 30 ohm, tell me which way the current is going to go. Am I going to end up with more current or less current? Take a stab at it. Show me with your thumb. So I'm going to take the resistance and I'm going to increase the resistance here. Okay. Does it look like the charges are moving faster or slower? What do you think, Addie?
slower.
Yeah. So right now I've got a current of 0.18. And so if I bring this back to my original, which was all the way down at 20, you see how the current and the resistance, there's the relationship, right? I equals V over R. So this is good stuff. Now, the second one, the voltage. Thank you, Addie. I'm going to see if, let's see here. Carter, can I pick on you? Is it okay to come to you to see what you think about voltage?
Yeah, it was kind of not really working for me very well, so I don't know if I measured everything that I was supposed to, but
Okay. Well, let me ask you this. Were you okay putting the black end? Because black is nighttime and it's scary, so it always goes to the negative end. Okay, if
yeah,
we're measuring it there at the battery. So you were able to get 10 volts at the battery, okay?
yeah,
Okay.
yeah,
And so you notice that the electricity has to go in at the black and come out at the red. So if I were to go up to this bulb up here, Carter, it's got to go in on that one. I'm going to move the red to where it's coming out there. So you
yeah.
were not able to get negative 6.67.
I did get negative 6.67.
Okay, all right. And then you did the same thing over here, black on the going inside
Mhm.
and red on the going outside. You got the negative 3.33?
Yeah, mine was just, I don't know if I did the wrong one. It was also just like flowing in a different direction, so I think I set it up
Okay, and I
correctly,
can
but
tell you why that is. I'm going to go ahead and change my screen up just a little bit. In the top right corner, do you see where it says show current, electrons versus conventional current?
oh,
You see how
yeah,
I've got
yeah,
conventional
I
current
got that one.
selected? That's the difference, okay? All right.
Yeah.
So Carter, let's put this together. We've got 10 volts at the battery. We've got 6.66 at the higher resistance. We've got 3.33 at the lower resistance. What gives?
Um, they both add up to 10.
Beautiful.
Like,
All right, now we're going to switch gears, and you might want to go over to your piece of paper. I'm going to go ahead and stop sharing there, and I'm going to write some stuff down for you because this is the big stuff about series circuits, and we'll just talk for a couple moments more, and then we'll be pretty much done for the day. All right, so about the current, it is the same everywhere, all right? And then the voltage, we would say that the voltage at the resistors added up to the total voltage from the battery. Because the battery is what provides the voltage, it's what provides the energy. And there's a simpler way of writing all this. So this is for a series circuit. And a series circuit is the type of circuit, and it's the simplest one, where you literally have one path. There is only one path from positive to negative. And the electricity has to go through one thing and then the next thing. And then if you put something else in it, through the next thing. There's no options, okay? It's very much a dictatorship. There is no democracy in a series circuit. It's not like, oh, I'm gonna go here, but maybe I'll go this way. There's only one path, okay? And so for series circuits, here's the rule, okay? If I want to know what's going on, and remember that the current is represented by the letter I, the current for the entire circuit, and sometimes you'll see it as I total, sometimes you might see it as I equivalent, but the thing is, it doesn't matter where you are in the circuit, all right? And I'm going to use some symbols here. I1, I2, I3, and so on and so forth. I'm going to draw myself a little simple circuit down here. This is the symbol for battery. I'm going to go ahead and put 3 resistors in this circuit. I'm going to call them R1, R2, and R3. So big idea number 1 here for a series circuit. The current that is flowing through this circuit is always the same everywhere. So the current going through resistor 1, I1, is exactly the same as the current flowing through resistor 2, is exactly the same as the current flowing through resistor 3, is exactly the same as the current flowing through the total circuit. So in a series circuit, current same everywhere. Easy peasy. Now, second rule for voltage, if I want to talk about the total voltage from the circuit, the total voltage from the circuit, all right, that comes from your battery. So I'm going to put V total right over here by the battery. And oh, my pen got all messy there. That's V total. Sorry about that, guys. My writing got all kinds of messed up. So V total is the voltage that is supplied by the battery. And I'm going to go over to, let's see here, if I can trouble Ethan. Ethan, each time I go through a resistor, it takes a little bit of energy to go through a resistor. Yes?
Mhm.
Okay. So let's say that, resistor 1 was maybe 1 ohm. We'll make it easy. Resistor 2 was 2 ohms, and resistor 3 was 3 ohms. Which one's going to require the most energy to get through, Ethan?
3.
Yeah. So not surprisingly, if voltage is related to like the oomph, the energy, where is most of my voltage going to get used up? Going through R1, R2, or R3?
R3.
R3. But at the end of the day, the voltage that I use up in R3 and R2 and R1, what do those voltages have to add back up to, Ethan?
6 or
Yeah, in that case, it would, well, let's see, that's the resistance. These three voltages.
just the initial voltage or like
Yeah, the total voltage. That's exactly right. So I'm trying to write this as, nicely done. I'm trying to write this as a little bit of a mathematical formula. So whatever voltage I have at resistor 1, plus whatever voltage I have at resistor 2, plus whatever voltage I have at resistor 3 has to add up to the total voltage. And Ethan, since I got you here and you already kind of let the cat out of the bag, the rule for resistance for the total circuit, if I say, hey, what's the total resistance of this circuit? A 1 ohm followed by a 2 ohm followed by a 3 ohm. You'd say the total resistance, Ethan, is?
the 6.
6. You literally, it is that easy. So we say resistances add up in series. So these are what we call the rules for series circuits, all right? And so with that, all right, you're going to have to kind of use your brain. I've got a little bit more problem solving stuff that I posted, and I said it's due tomorrow. Get it done. And you probably have some time to work on it tomorrow as well. And what we'll do is we'll build on this a little bit because I'm already at 30 minutes here, or getting close. And what we'll do is we'll get a little bit better about analyzing series circuits. And that is pretty much what I wanted to go through there lesson-wise. I'm going to go ahead and stop recording.